Indonesia audio narration only on paid version. Audio narasi bahasa Indonesia tersedia di versi berbayar.
In various traditions of physical culture, meditation, and martial arts, we often hear a classic piece of advice: breathe softly, slowly, and deeply. For centuries, this instruction was understood as a qualitative technique to calm the mind, control emotions, or reach spiritual depth. It has had many names, from pranayama to various traditional breathing practices across the Indonesian archipelago. However, when modern medical science investigates what actually happens inside our blood vessels and nervous system when we practice soft and deep breathing, a remarkably measurable physiological phenomenon is revealed. In medical science and neuroscience, this phenomenon is no longer described qualitatively, but measured quantitatively as resonant breathing, or resonant frequency breathing therapy. The main difference between traditional and medical terminology lies in the perspective of measurement. First, the traditional term, soft and deep breath. It focuses on physical sensation, air entering and leaving without sound, without jerkiness, with its duration extended. Second, the medical term, resonant breathing. It focuses on a measurable mechanical effect, a breathing pattern lowered to achieve a precise rhythm of 4.5 to 6.5 breaths per minute, or about 0.1 Hz. Why must it be soft? Medically, if we try to breathe slowly but with a harsh or rushed airflow, the lungs fill up too fast in the first 2 seconds, forcing us to hold our breath for the remaining seconds. The term, soft, is a mandatory mechanical requirement so that air is distributed steadily over 5 to 6 full seconds during inhalation, and 5 to 6 full seconds during exhalation. Without a soft airflow, physiological resonance rhythm can never be achieved. In the general public, breathing is often viewed as first aid during panic or merely a way to relax for a moment. However, in integrated medicine and modern psychiatry, resonant breathing is studied and applied as a non-pharmacological clinical intervention. This means its standing is equivalent to physical therapy or a companion prescription to medication. Through heart rate variability biofeedback measurements, doctors and researchers discovered that when we breathe at our natural resonance point, first, the autonomic nervous system immediately shifts from sympathetic dominance, or alert mode, to parasympathetic dominance, or recovery mode. Second, internal blood pressure sensors, or the baroreflex, undergo a reset or recalibration. Third, signal traffic through the vagus nerve dampens hyperactivity in the brain regions that regulate anxiety and stress responses, specifically the amygdala and the default mode network. The soft and deep breath, passed down by ancestral traditions, is not a myth or a mystical claim. It is an intuitive, ancient method for operating our body's biological switch, a switch now mapped with precision by modern science to help intervene in various chronic conditions. To understand why resonant breathing works so powerfully inside the body, we need to uncover the mechanism behind one of the most crucial numbers in neuroscience and cardiology, 0.1 Hz. This number is not a random formula, but a mathematical intersection between the way we breathe and the natural frequency of our vascular system. In physics, Hertz is the unit used to measure frequency, meaning how many cycles of a wave occur in 1 second. The basic formula is simple. Frequency equals 1 divided by the duration of 1 complete cycle in seconds. Let us calculate our body's breathing patterns. First, normal breathing. When we engage in everyday activities, we breathe about 12 to 15 times per minute. This means one complete breath cycle of inhaling and exhaling lasts about 4 to 5 seconds. Its frequency sits between 0.2 Hz and 0.25 Hz. Second, resonance breathing. When our breath settles at a rhythm of 6 breaths per minute, one full breath cycle takes exactly 10 seconds, 5 seconds inhaling and 5 seconds exhaling. When put into the formula, one cycle divided by 10 seconds equals exactly 0.1 Hz. Therefore, 0.1 Hz means that in 1 second, 0.1 of a breath wave occurs, or it takes exactly 10 seconds to complete one full breath wave. Why is this 0.1 Hz, or 10-second cycle, so special for our body? The answer lies in the automatic blood pressure control system called the baroreceptor reflex, or baroreflex. First, signal time delay. In the blood vessels of our neck and chest, there are pressure sensors called baroreceptors. When blood pressure rises, these sensors send signals to the brain to slow down the heart rate. Conversely, when blood pressure drops, the brain instructs the heart to beat faster. Second, the 10-second cycle. This back-and-forth process, from pressure changes to sending signals to the brain, to the heart's adjusting response, requires a natural delay of about 10 seconds from start to finish. Third, natural oscillation. Because of this 10-second delay, our cardiovascular system naturally oscillates up and down at a frequency of 0.1 Hz. This is the natural swinging rhythm of the human cardiovascular system. When we breathe at a rhythm of 6 times per minute, or 0.1 Hz, it is like pushing a swing right at its turning point. Our breath suddenly locks in and synchronizes with the natural rhythm of our blood vessels. This alignment phenomenon is known as entrainment. At this moment, 3 vital bodily waves that usually run independently suddenly unite in a single rhythm. The lung wave, or the rise and fall of air volume. The heart rate wave, or the acceleration and deceleration of heartbeat. The blood pressure wave, or Mayer waves. When these 3 waves align at a frequency of 0.1 Hz, our heart rate variability chart spikes to its highest peak of resonance. The heart works with extreme efficiency. The heartbeat slows down maximally as we exhale, and accelerates as we inhale. This resonance wave in the blood vessels does not stop at the chest. Every time blood vessels expand and contract in the 0.1 Hz resonance rhythm, baroreceptors fire massive electrical impulses along the main pathway of the vagus nerve. This rhythmic signal travels straight up to the nucleus tractus solitary in the brainstem. As soon as this 0.1 Hz signal is received by the brain, for stress reduction, the brain registers a physical signal that the body is in absolute biological safety, shutting down the fight-or-flight response from the amygdala. For mental calming, the brain network responsible for internal monologue and wandering thoughts, the default mode network, experiences a drop in spontaneous activity. This is the engine behind bodily resonance. We are not forcing the mind to calm down, but rather using the 0.1 Hz mechanics in the lungs to lock our entire circulatory system and brain into their most optimal recovery rhythm. Now that we understand that the 0.1 Hz rhythm acts like a biological switch resetting our nervous system and blood vessels, the biggest question is, what medical conditions or diseases are clinically proven to benefit from this resonant breathing intervention? In modern medicine, this technique is officially applied through heart rate variability biofeedback protocols, or resonant frequency breathing therapy. This is an evidence-based intervention recognized across various medical specialties. Here is the map of health conditions and diseases that can be intervened by this breathing rhythm. In cardiology and the cardiovascular system, the blood circulation system is the primary organ directly connected to the mechanical effects of breathing resonance. For essential hypertension, or high blood pressure, people with hypertension often have blood pressure sensors, or baroreflexes, that are blunted or miscalibrated due to chronic stress and arterial stiffness. When we apply resonant breathing, mechanical stimulation on blood vessels retrains baroreflex sensitivity. As a result, blood vessels become more flexible, peripheral resistance decreases, and both systolic and diastolic blood pressure gradually drop to safe levels. For mild arrhythmia and post-heart attack rehabilitation, following heart issues, the body tends to stay in sympathetic dominance, or an overactive alert state, which increases the risk of heart rhythm disorders. By regularly activating parasympathetic tone through soft 0.1 Hz breathing, heart rhythm becomes significantly more stable, and the workload on the heart muscle is dramatically reduced. In psychiatry and mental health, the brain and the autonomic nervous system communicate bidirectionally. When the brain experiences emotional dysregulation, the body feels the impact. Conversely, by manipulating bodily rhythm, we can soothe disturbances in the brain. For generalized anxiety disorder and panic attacks, when anxiety strikes, breathing unconsciously becomes shallow, rapid, and irregular. This triggers a buildup of threat signals to the amygdala, the brain's fear center. By lowering the breathing rate to the resonance frequency, physical signals from the vagus nerve instantly cut off those threat signals, halting the escalation of panic attacks at the physiological level. For post-traumatic stress disorder, or PTSD, individuals with trauma are often trapped in somatic hyperarousal. Their bodies constantly feel in danger even when their surroundings are safe. Resonant breathing provides somatic safety signals, or bodily-based feelings of security, helping reintegrate emotional regulation without relying solely on cognitive analysis. For major depression, neuroimaging studies show that individuals with depression have very low heart rate variability and an overly dominant default mode network. Resonance breathing therapy helps elevate heart rate variability values and calm default mode network hyperactivity, making it a highly effective adjunctive therapy. In neurology and chronic pain management, pain signals are not merely processed at the site of injury, but are regulated by the central nervous system in the spinal cord and brain. For chronic pain and fibromyalgia, according to the gate control theory of pain, the transmission of pain signals from the body to the brain can be inhibited or amplified by autonomic nervous system stress levels. When we increase parasympathetic tone via the vagus nerve through resonance breathing, the pain transmission gates in the spinal cord undergo partial blockage, reducing the perception of pain felt by the body. For migraines and tension headaches, are heavily influenced by sudden constriction and dilation of blood vessels in the head caused by autonomic fluctuations. Resonance practice helps stabilize vascular tone, minimizing the frequency of headache attacks. In pulmonology and respiratory disorders, for asthma and chronic hyperventilation, asthma sufferers often have airway hypersensitivity to stress responses. Furthermore, rapid breathing patterns lower the carbon dioxide tolerance threshold in the blood. By maintaining a soft, deep breathing pattern at the resonance frequency, we retrain the breathing center in the brainstem to be more tolerant of carbon dioxide, while reducing the tendency for stress-induced airway constriction. The standing of resonant breathing across all these conditions is not as a substitute for medication or primary medical procedures, but as a foundational therapy. This technique conditions the body's biological terrain to reside in its most optimal recovery mode, allowing conventional medical treatments to work far more effectively. Many people assume that to achieve resonant breathing, we must force our chest or belly muscles to work hard at artificially slowing down our breath. This is a fatal misconception. Forcing or holding our breath actually sends threat signals to the brain, which triggers a stress response instead. A soft, deep, and slow breath is not a forced exercise, but a natural result when our body shifts modes. The key is not in forcing breathing muscles, but in operating 3 sensory awareness anchors to execute an immediate mode switch. When we execute these 3 sensory steps, the body naturally slides into resonance breathing mode. First, exteroception, broadening peripheral vision. The first step begins with the eyes. When we are in a state of stress or tense analytical focus, our eyes are locked in focal focus, a sharp, narrow vision on a single point ahead. This sharp focus is directly connected to the activation of the sympathetic nervous system. To shift modes, without moving your eyes to the left or right, soften your gaze. Allow your visual attention to bloom and widen to the far left and right corners of your field of view. Maintain a forward focus, but become aware of the outermost edges of space to your left and right simultaneously. This broadening of peripheral vision neurologically dampens sympathetic drive in the brain and instantly opens the gateway to the parasympathetic nervous system. Second, interoception, drawing attention inward. After softening outward vision through peripheral sight, the second step is shifting the focal point of our attention from the outside world into the internal space of the body. Whether with eyes closed or gently open, draw awareness inward into the chest and abdomen. Feel the physical sensation of air flowing behind the nose, the expansion of the chest, and the gentle movement of the diaphragm. We are not judging or controlling the breath. We are simply acting as a witness to the movement of air and the physical rhythm taking place within us. This inward interoceptive attention directly lowers brainwave frequency from beta toward alpha. Third, proprioception and tactile anchoring, building density of awareness. The third step is combining internal awareness with the physical tactile sensation of the body against its support. Feel the physical contact points of your body right now, the touch of your soles resting on the floor, the pressure of your hips and thighs against the chair, or the weight of your hands resting in your lap. Feel gravity working on your body. Become fully aware of your body's physical weight. The fusion of internal attention and tactile support creates what is known as density of awareness. The body feels weighty, solid, grounded, and truly present in this moment. The instant effect, entering resonance mode naturally. The moment these 3 sensory anchors connect, vision blooming into the periphery, awareness drawn inward, and the body firmly anchored to its foundation, the central nervous system detects the highest level of biological safety. Instantly, without needing to count or force, the body's breathing rate slows down on its own. The airflow becomes exceptionally soft, inhalation and exhalation durations naturally lengthen to an even 5 to 6 seconds, and the entire circulatory system locks into the 0.1 Hz resonance frequency. Anyone practicing this sensory anchor shift will immediately feel a tangible mode change. Shoulders drop, facial muscles relax, the chest opens up, and a solid calm rises from within. Resonant breathing, or soft and deep breathing, is not a magic spell, nor is it a complete replacement for modern medical care. This technique holds a highly respected and strategic position in integrated health science, as an adjunctive therapy and a self-regulation modality. Conditioning the biological terrain. In managing chronic conditions, whether hypertension, anxiety disorders, PTSD, or chronic pain, medications and medical interventions act directly on the body's biochemical targets. However, the effectiveness of these treatments is heavily influenced by the condition of the internal environment, or the biological terrain. If a patient's body remains in chronic stress, blood vessels stay constricted, the stress hormone cortisol impairs tissue repair, and the immune system is suppressed. This is where resonant breathing plays its vital role. First, creating a foundation for recovery. By regularly entering the 0.1 Hz mode for 15 to 20 minutes a day, we condition the autonomic nervous system to stay in recovery mode. This creates space for medications and medical procedures to work with the best possible physiological response. Second, training neuroplasticity. This routine practice recalibrates the brain's stress tolerance threshold, ensuring our body does not easily get thrown into panic or overactive alert modes in daily life. Reoperating the internal switch. So often in our search for healing, we busy ourselves looking for external interventions. We forget that the human body is equipped with an extraordinarily sophisticated self-regulation mechanism. The traditional term, soft and deep breath, and the medical term, resonant breathing, ultimately express the exact same truth from two different eras. Through modern scientific understanding and precise use of sensory anchors, we now possess the scientific key to turn on that internal switch. By aligning our breathing rhythm with the body's natural frequency, we are granting our body the right to heal, balance, and restore itself.
Thanks for watching. Find out related video on number 4 playlist.